Okay, so this week we've talked about square roots. We've talked about rational and irrational numbers. And we've even approximated the value of a square root. Well, there's also something you're going to see this year called a cube root. So before we get into that, let's review what we've done this week. We talked about what a perfect versus a non-perfect square is. So if we take a look here, we did this in class the other day. 9, 121, 1, 64, and 324. Those are perfect squares. Why? Because a number times itself will result in these answers. Like 9, that was 3 times 3. So a square root, a perfect square, has just two numbers. Okay, so let's keep that in mind. These were non-perfect square roots. What we did the other day was we approximated them. We found which two perfect roots they lie between. So all we're going to do in this section is we're going to decide what two perfect square roots does this number lie between. All of these, 10 through 15, are irrational numbers, okay? So let's take a look. Think about 10. Think of your perfect roots. You should know that it lies between 9 and 16. Therefore, it lies between 3 and 4. This page is critical that you understand this. Okay, so let's think of 115. Think of your perfect squares. And if I would get in the habit of this, I would write them down. So you should know that the perfect squares, and you can just start doing it. 1 times 1, 2 times 2, 3 times 3, 4 times 4. Write those answers on your sheet of paper. Because watch how quick it'll be. Well, if you had those all written down, which you do on the other side of this page, you would know this falls between the square root of 100 and 121. Therefore, it's 10 and 11. Those are the two consecutive integers that the square root of 115 falls between. Let's look at the square root of 59. This falls between 49 and 64. Therefore, the actual value of the square root of 59 falls between 7 and 8. So whenever you're doing these, the answer to number 10 would be 3 point something. The answer to number 11 would be 10 point something. And the answer to number 12 would be 7 point something. So I'm going to pause, and I want you to try the last row. Same exact thing, except instead of in front of your answer, you're going to have a negative sign. Okay, let's look. You should have gotten square root of 36, square root of 49. So the answer to this problem falls somewhere between -6 and -7. So your answer is going to be about -6 point something. This one should be negative square root of 1, negative square root of 4, meaning your value is going to be between -1 and -2. Then you have negative square root of 206, which is between -196 and -225. So between -14 and -15. You're going to be asked to approximate where these fall on a number line. So we have to first understand between what two numbers does it fall. Okay? So make sure you have this. So let's go now and approximate again. Yes, we did a video on this last night, and we did some in class today, but you need to know how to do this. So we just did 6 examples. Our first step, what 2 does it fall between? That is step 1. Well, this is the square root of 81 and the square root of 100. We actually take their square roots. So that's 9 and 10. Now remember, step 2 is we're going to create a ratio. We're going to take the irrational number we're looking at, which is 84, and subtract from it the smaller root, which is 81. Then on the denominator, I find the difference of my two consecutive integers. So I do some subtraction, and I get 3 over 19. Remember, I divide, okay? You're going to take and approximate it to the nearest tenth. So if I were to put 3 inside your house, 19 outside, you get 9.2. Let's look at number 17. The two perfect squares it lies between is negative square root of 25, negative square root of 36. So our answer is somewhere between negative 5 and negative 6. Okay, so we're going to subtract. We're going to do 27 minus 25 and over 36 minus 25. I'm then going to get 2 over 11. I do some division and end up with negative 5.2. It just so happens both of them are 0.2. That's not always going to be the case. Okay. I want you to try this one on your own. I'm going to look for it. It's okay if you don't understand it. Try it. Mirror what we did in 16 and 17. If you get it right, I will give you a bonus point on the homework. Okay, so now that our review is done, that takes us to what is a perfect cube. And we kind of touched on this when we were doing perfect squares. Well, the cube of an integer is called a perfect cube. So anytime you have an exponent of 3, if you look at all of these, this is 1 cubed, 2 cubed, 3 cubed. And I'm going to use cubed a lot. I'm going to use that versus to the third power. What does that mean? But it's a number times itself 3 times. So 1 cubed is 1 times 1 times 1. 2, which is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. Now, you're able to find these answers because you can multiply, but you need to have some understanding of them for when you need to find the next part. So if we go through, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. I'm going to say you should know up to about 6 cubed off the top of your head because you will see those a lot. So if cubing a number is called a perfect cube, the opposite of cubing is taking the cube root, just like taking the square root. Now, this one's a little different. When we had a square root, there was always 2 square roots. But this one only has 1. Okay, well, why is that? Well, what number can you cube to get a positive 8? The only number there is a 2. Because a positive 2 times a positive 2. Okay, you have 3 numbers this time. But in order to get another negative, a negative 8, you'd have to have a negative 2. Okay? So again, this symbol is called a radical symbol. But if you look closer, and I'm going to go back for a second, and I want you to see something here. I'm going to highlight it. Okay? See this right here? This little 3? That is called the index. The index is what changes the root. That little check sign that a lot of people call a square root sign, that's actually a radical sign. But this becomes a cube root because there's a 3 sitting right there in that little house, okay? So we would say the cube root of x. So let's find the cube root. There's some we should have memorized, like I said. So if you go back and look, the cube root of 64. Well, what times itself 3 times gave me 64? It's on your page. Okay, so you're looking, what number could I place in here? Times, it's the same number that's going to go in each one. You should have said 4. So see that 3 times, same exact number. Looking at your page also, 343 should be 7. Now look at 19 and 20. There was no negative sign inside. So that's how I know my resulting answer was positive. If I look at this next one, 21, it's the cube root of negative 27. So what am I going to do to get a negative answer? multiply a negative number because it's a cube root, so -3. So notice I gave you -13 here. I don't expect you to know that without a calculator, so just write that one in. We're not even going to waste our time with it. It's just too high. And I will show you how to use a calculator when we get to calculator sections. But so far, everything you've learned this chapter is a non-calculator day. So I want you to try 22 and 24 on your own. Okay? I'm looking for those answers. That's it. We're done for the night and you're done for the week. Not too bad. So if you don't understand something, please let me know. We're going to spend some time practicing. This is a rather quick chapter. We have maybe one more topic. Okay? So please, please, please ask.